Georeferencing is a process of assigning CRS and coordinates to otherwise unreferenced image. This is the first step that happens when you create a satellite image or a drone image, or you have an old map. You need to place this somewhere on the Earth's surface. You need to decide what is the coordinate system you're going to use and where does it fit on the surface of the Earth. Most of the time, when you download data, GeoTIFF files, they'll have the projection information already there. It would be already georeferenced data, and you can use this. There are instances where you may have to work with images which are non-georeferenced. Let's say you took a hot air balloon flight and you had a phone, you took some photos of the ground, and you want to come in and create a map out of this. That photo doesn't have coordinates information, but you can say, I can identify some points here. I'll assign those coordinates to a few points in my image. You can warp it and fit it there. Similarly, if you had an old map which didn't have any coordinate system, you want to georeference this, you can use this. So this is typically, again, done by drone imagery. If you fly a drone image and you get your mosaic, you finally have to assign some type points and georeference that. If you use QGIS for doing this, many of you would have done this process in QGIS. QGIS uses GDAL under the hood to do georeferencing. We'll learn how does GDAL handle georeferencing. If you want to do batch georeferencing, GDAL has some really useful commands that might save you a lot of time and effort if you had this use case. So let's start working on it. We'll open this data in QGIS. So in your data package, I have one file that I put, earthatnight.jpg. This is a nice image I downloaded from NASA. They're saying, do you want a nice wallpaper of nighttime lights? Download this. Right? So this is just a plain JPEG image meant to be used as a wallpaper. But let's see if you want to assign it some coordinates and put it on Earth so we can kind of see how does nighttime lights look at your own city. Right now we can't do this. It's just a plain JPEG image. So if I go to my terminal and ask GDAL info earthatnight.jpg, let's say GDAL info earthatnight.jpg. GDAL info can read this, but you can see there is no coordinates. This is just, the coordinates are just lines and columns. There's no coordinate systems here. So there's no CRS, there's no projection. So it's just a simple JPEG image. If I load this into QGIS, it opens, but you can see I see a warning here. There's a question mark. Layer has no coordinates reference system set. Right? You can't load this. If I use our trick to load the georeference world data, you can see I loaded the world maps layer. It loads here. These are the actual georeference data, but my image doesn't sit on top, right? Because it's just plain JPEG. So how do I make this image sit on top of this exactly where it belongs so I can combine it with other data? So that's a process called georeferencing. We're going to learn about two techniques. The first technique is where you have an image where you know the coordinates of the four corners. If you have any image, whether it's a world image or a country's image, if you know the coordinates of four corners, it's very, very easy to assign a CRS to that particular file. Do we know the corner coordinates of this image? Yeah, we know the corner coordinates because this is the global image. Equator is 0 degree in Y direction. If you go up, the Y coordinate at the top is 90. At the bottom is minus 90. It is minus 180 in the X direction here, plus 180 in the positive direction. So now we can know what is the coordinate of each corner. And we can just say, put those four things at the corner. And that coordinate system that we are using is lat long. So we can say the CRS is EPSG 4326, and these are the corner coordinates. If you have this, we can georeference this automatically using GDAL. Let's see how to do this. We can go to GDAL Translate. GDAL Translate has this very mysterious looking option called AULLR. This says assign upper left, lower right. That's the option. That means if you know the coordinates of upper left pixel and the lower right pixel, we can georeference that. So we can say upper left X. What is upper left X? Minus 180. Upper left Y plus 90. Lower right X is positive 180. Lower right Y is negative 90. So If we give this to 4 coordinates, we can assign a CRS to this. Let's try this. So from our terminal, we'll just say GDAL translate. We're going to use this option -a ULLR. And we need to give the coordinates of upper left and lower right. So this is upper left X, upper right Y, upper left Y, upper right X, and upper right Y. So these are the 4 coordinates. Since it's a global image, we know what is this. This one doesn't have a CRS, so we can use -a SRS and say we want to assign a CRS to the original data, EPSG 4326, that long. And we can take our Earth at night and we'll say we'll turn it into Earth at night.tiff now. And we can apply a standard TIFF compression. Run this. And let's check GDAL info of the Earth at night.tiff, which we just created. Now you see the difference? It says we have a CRS of this file. We have the pixel size. And we have the coordinate codes of all of those coordinates we did. So we just assigned CRS to this. Let's load this in QGIS. I have my world map. I can load Earth at night.tiff. And it sits exactly on top of my data. So now I can go and say, how does my city look like at night? And it just goes and shows me exactly where it is. Okay, so now I georeference this JPEG file just using one command. Imagine you had a batch of those. You can just automatically georeference them without doing anything manually. And this will be very precise. We don't make a mistake because we are just assigning those based on the coordinates.